What is up, everybody? Welcome back to Case Digital. My name is Zach, and in today's video, we're going to answer the question of how to do selection sort in Python. So for example, I have this starter code right here where we're basically going to generate a random list that's in a random order, print it out, show what it looks like, and then we're going to do this selection sort algorithm, which we'll get up here and write together, and it'll come out as an ordered list. So as a kind of a precursor to what you're going to see, is essentially we'll run this and you'll get a random list that is in a different order, and then we're going to go and order that list using the selection sort algorithm. And look, it even handles duplicate entries. And so without further ado, let's hop right in and start coding. All right, before we get into the actual creating of the algorithm in Python, I want to explain a little bit about this selection sort algorithm and a little bit kind of like what it is and how it works. So if we pull this up here, essentially what the selection sort algorithm is going to do is it's going to start at the very first index. It's going to loop through each one of these, indexes in this array. It's going to find the smallest value, and then it's going to put it at the very front. And then what it's going to do is then start at the next index, and then just basically go through this process of looping through a smaller part of the list each time until it has finally found all of the different all the different smallest indexes and put them in the right order. So as you can see from this example is it went through, started with 4 at the index of 0, went through and found that out of this whole list that 4 is the smallest value, so it's going to place it or keep it at index 0. The next thing it's going to do is start at index 2 or index 1, I guess in this case, and it's going to say, oh, there's 31. Let's go through, find the smallest value. It's going to find a 13. It's also going to find another 13, but it's probably going to stick with this 13 because it's just going to do if it's less than. And then it's going to go through and say, oh, there's 13. Let's put it there. And then it's going to start at the original list and do index 2. And then it's going to go and find like, oh, there's the 13 right here because this one would have been gone. And then it's going to put that one at index 2 and so on and so forth until we get our ordered list. So that's kind of how selection sort works. If you have any questions, leave them in the comments below. But I'll talk a little bit, but I can write something that can help visualize that, which would probably be better, to be honest. But without further ado, let's hop into the algorithm and show you how you can code this up so that I could actually do this while using Python. All right, so hopping right into the creation of the selection sort algorithm in Python. Essentially, like I mentioned, we're going to have to loop through this whole list, and we're going to have to loop through it multiple times. So what I like to do is essentially you're going to get the length of the list, and you can essentially do so. We'll say array, or I like the length array is equal to the length of R. Now, what that allows us to do is we can kind of create. We're going to have to loop, since we're going to have to loop through this multiple times, but then we're going to want to keep track of kind of like that first of the index that we're at, and then as we loop through it again, we're going to have to move that. This is going to essentially end up being a double for loop. So to do that, we're going to start with our first for loop, and I'm going to say for I in the range of the length of the array, because again, we have to go through that whole length, right? And we're going to go through it multiple times. So we're basically going to say that the current index we're going to assume as the smallest value. So or the value at the current index we're going to assume is the smallest. So we're going to say the min index is going to be equal to I. Whoops, not 1, I. Now what we're going to do is we're going to go through and loop through the, taking that index plus 1, and we're going to go through and loop through the rest of the list. So we're going to say for j. This is a common practice. A lot of people put I and j as their for loop stuff. I do this a lot in C++ for sure. So for j in, and we're going to say range of, and we're going to start from I plus 1, because this is where we're going to start comparing. So our current one was saying at index I, and now we're going to start comparing is from I plus 1 onward, right? So that's kind of what we're going to do here. So, and then this is going to be the length of the array. All right, so we've kind of got that set up. So now this gives us the framework to essentially go from I and then just kind of start at I. And then it's going to give us the ability to say, okay, we're at I, loop through everything else. Okay, update I to this position, then loop through everything else, update I to this position, and loop through everything else. And then just keep going until we finish, right? And by the time we're done, we should have put everything in the correct order. But to do that, we then also need to say, hey, if the array at the index of j is going to be less than the array at the min index, right? Because we want to say, hey, we're assuming that the min index is the current position of I. Then we're going to, Control Z. Oops, I need to put a colon. There we go. Then what we're going to say is that the min index is going to be equal to j. So that just basically means that as we start at I, and as we're looping through, we're going to find that min index, and then we're going to say, oh, hey, the min index is actually over here. So we now need to take that variable and swap it with the other variable, right? So that way it puts our actual min index in the correct position, which is where we want to put it, is right at that whatever I originally is. So to do so, we'll have found that. And then we'll come out here of the for loop, and we're going to say array of j, or no, array of I, because that's the current index that we're looking at, and that's the index that we want to place something into. And the array of whatever the min index that we found, we're just going to swap the variables. So we're going to say array of min index, and this is how you do the variable swap, and array of I. And then, to be honest, that is the actual algorithm. And then you just make a return, and we're going to print out array. So if we run this again, barring that we didn't make any mistakes as we were coding this live, you should see that these are sorted. So we'll reset and run it. All right, so here's our original list. And then here is the ordered list. So we can see 4, 8, 16, 18, 24, 26, and it looks like they are all in order. So again, this is kind of what happened. So to explain this more in detail with context, so this, when we do our first loop, this is going to be the position of I. What's going to happen next is we're going to say now, this is our outer loop. So we're going to say we're going to loop through this whole thing. Basically, we're going to loop through, the I is saying I'm just going to go from this to the end, and just ideally one time. But then we have an inner loop, which is going to say j is going to be I plus 1, so that'll be this all the way to the end. And what we're going to compare is, what we're saying is the min index is currently here, all right? And so that's why we're saying the min index is currently here, I is currently there as well. We're going to loop through this portion of the array, and we're going to compare as we're looping through index j. So this will be j, and then we're going to say, hey, is j less than the current min index? And so our current min index, again, remember, is 30. So yeah, 24 is less than 30. So now we're going to say that the min index is at index 1, right? Or this is index 1. So then we're going to keep going, and we're going to say, well, if now j moves up because we're going as 18, then it's going to find, oh, well, this now is the min index. And then, oh, this is the min index. Oh, this is the min index. Oh, this is the min index. And then it's going to say, oh, hey, 4, that's the min index. And no, like 4 is the actual, by the time I've gone through and looped through this portion of I, for I being 0, it's going to say, hey, 4 is the min index. So it's going to take this value and swap them. So now your list will essentially be 4, 24, 18, 42, 16, 8, 30, 26, 32, and 33. And then it's just going to say, okay, now I is this position, because we found the actual min of the list. We found it and we're putting it right here. So now I is going to be this spot. And we're going to go through, and remember 30 will be here. And actually, I wonder too, let's do this. So then I can say, let's print out the array, and this will actually show this. Yeah, this should show it. So if we put that print in there, oh, now it's a different value because I have a random list. But so here's how it started out. Here is the current list. All right, so here's the current list, and basically we've already done the swap. Actually, let's do something like this. This is going to be, make this an F string. This will be after. And then, oops, man, there we go. And then we'll do a before a swap. And maybe we'll indent this a little bit. All right, so if we go ahead and rerun this, again, the numbers will be different because we have an algorithm that's sorting it. But all right, so we start out with this current list, and then this is what it is before the first swap. So we have this is the values, and what happened is afterwards it went through and it found that the lowest value is 7. So you looked at 7 and 18 got swapped, right? And then we go to, now we're saying that, hey, index I is now at index 1, and then it goes through and finds that, oh, 14 is the next smallest value. So 26 and 14 get swapped right here. And now we're saying I is at index 2, and then it's going to go through and it's going to find that 28 is going through and finds that, oh, the smallest value is 18 out of all these. So we're going to swap 28 and 18, which you can see there. And then it's going to keep going all the way till the end, where it's going to say, oh yeah, this is basically the very last one is it's already in order. I is now at index the last value of that list. I think this is a size 10 list, so it should be at index of 9. And then it's going to say, oh, there's nothing left, so that's it. And then it's going to return the ordered sorted list, which as we look through this carefully, 7, 14, 18, 25, 26, 27, 28, 28, 46, and 49, we see that is actually ordered. So that is the selection sort algorithm. And if you look at it, I mean, it's not actually a lot of code, right? It is, if I take out the prints, I mean, it's like right here, it shows it's like 8 lines of codes, or 10 lines of code, essentially. But I mean, in just a simple amount of time, we are essentially trying to go and say, hey, I'm starting at this index, find the smallest value, put it at that spot, or swap them and put it at that spot. Then go to the next, find it, and just so on and so forth till the end. So if you found this value, please hit the like button below. If you have any questions, please leave comments. And if you like a visualization, like a program that kind of visualizes sorting while it happens, please type something like visualization in the comments below, and then I'll go ahead and make a, whether it's leveraging, different technology or stuff that's already out there, I'll try and go ahead and write a little app that you can put in a sorting algorithm, or a little program that you put in a sorting algorithm, such as selection sort, and it'll visualize kind of like it's sorting the everything using that algorithm. So I hope that you found this helpful, and until next time, keep on programming.